Well, let's use our powers of differentiation right here in order to find a derivative of another trigonometric function. Here it is, 1 plus sine of x over cosine of x. And, well, looking at it directly, this is definitely a quotient rule kind of problem again. So if we're finding the derivative, the way that we're finding it is this way. We're going to have the square of the denominator, square of cosine of x. And in the numerator, we're going to have the denominator, cosine of x, multiplied by the derivative of 1 plus sine of x. I'm going to write that out. The derivative with respect to x of 1 plus sine of x. And we're going to subtract from that the quantity 1 plus sine of x. And that'll be times the derivative of the cosine of x. Alright, so following this through, let's see what's going to happen. We're going to cosine of x times, let's see, this is going to be 0, the derivative of the constant, plus cosine of x, which is the derivative of sine of x. We're going to be subtracting from that 1 plus the sine of x times, what do we say here? This was the negative of the sine of x, if we recall correctly. Of course, we are correct, right? Because this is cosine squared x down here in the denominator. Simplifying a little bit, I've got cosine squared x here. Let's see. This negative here can be multiplied by this negative here to give me plus sine of x no, that's it. Sine of x times 1 plus sine squared x. And this is over cosine squared x. Isn't that interesting? Look at what's going to happen. We're going to get 1 plus sine of x divided by the square of cosine x. Interesting. Well, that's our derivative right here. I might point out just a quick note right here and see if you can make anything of it. Don't forget that, if I have a function like 1 plus sine of x over cosine of x, you might note something. That's really the same thing as 1 over cosine of x plus sine of x over cosine of x. And, well, you know that 1 over cosine of x is the secant of x plus sine of x over cosine of x, that's tangent of x. And, oh my goodness, doesn't that look familiar? Can it be shown that these two are the same? Well, that's an exercise for you to do. Good luck.